Hello, today we will be talking about standing waves. After watching this video, you should be able to differentiate the difference between a traveling wave and a standing wave. And then also you should be able to identify a node and an antinode in a wave. So let's get right into it. What is the difference between a traveling and a standing wave? Well, a traveling wave is something that's really not confined to a certain area. So for instance, like the water waves out in Lake Michigan, or sound waves in a room. They're not stuck on something compared to, say, like the waves that you might create on a guitar string. Okay, it's basically stuck on that guitar string. So traveling waves are not confined to a certain area, whereas standing waves are. And the ability, or the way to make a standing wave, is you need to have waves of the same frequency and amplitude traveling in opposite directions. And when they meet, a standing wave is produced. Okay? And basically a standing wave is a wave in which certain points, or nodes, appear to be standing still, and other points, antinodes, vibrate with a maximum amplitude above and below the axis. Okay, and again, I think a picture will really help explain this. So we'll take a look at that right now. Actually, I lied. But we're going to take a look at nodes and antinodes. So a node and antinode are formed when a standing wave is produced. A node is going to be an area where there is no displacement in the medium. It would actually appear that nothing's happening there. It's just completely standing still. Whereas an antinode, it's just the opposite, is an area of maximum displacement. And that's what an antinode is. So again, I think a picture will be useful in looking at this. Here it is. This is a standing wave, and I'm just making this up. But let's say this top wave is moving this direction, and this bottom wave, which would be right here, is moving this direction. Okay, they're moving in opposite directions, but they have the same wavelength and same amplitude, and that's the definition of a standing wave. So here at this point, this is an antinode, okay, where basically you have maximum displacement going on. And a node, you have a point where there is no displacement whatsoever in the medium. Okay. One thing you should notice is you will have one more node than you will antinodes. So if you say, oh, I've got 3 nodes, then you will have 2 antinodes. Or if you have 4 nodes, you'll have 3 antinodes. So there's always one less antinode than there is nodes. So let's take a little example about like how you can maybe use this stuff. While children are playing, while children are playing, 2 children create a standing wave in a jump rope, as shown in the diagram below. What is the wavelength of this standing wave? Okay, and you'll notice these 2 kids are 4.3 meters apart. Okay, the definition of a wavelength is basically going from one point all the way to the other point of the wave. Okay, so basically from this kid to this kid, that's half a wavelength. And I know that half a wavelength, or lambda over 2, equals 4.3 meters. Right? Well, what's a whole wavelength? Well, I'm just going to double that, right? A whole wavelength would equal 8.6 meters, and that would be the answer. Basically, the wavelength of this standing wave would be 8.6 meters. Let's take a look at another example, and I apologize, this picture is not the best. It says the diagram below represents a wave moving toward the right side of this page. Okay, so you got this wave right here moving to the right. Okay. Which of the waves shown below could produce a standing wave with the original wave? All right. Right away, we can eliminate one, and the reason why is because it is moving in the same direction, even though this arrow isn't very clear. It is moving in the same direction as this wave, and that breaks the rules, right? We can't use that. If I look at 2, right away I have a kind of a problem with it, because the amplitude of this wave down here in the bottom is quite a bit more than the amplitude of the wave up here, and so that's a no-go also, so we can get rid of that one. 3 is looking pretty promising because the arrow is pointing the opposite direction of which this wave is traveling, and the amplitude looks to be about equivalent, and the wavelength looks to be about equivalent. But I'm going to take a look at 4 real quickly here. 4 has a very tall amplitude, and it doesn't look like it will work. So 4 is a no-go, and actually 3 would be the correct answer. Alright, and that takes care of today's video. I will see you guys next time.